Most investors think they know how to profit from artificial intelligence. Buy the companies building the smartest models. Buy the companies creating the most popular applications. Buy the companies getting the most headlines. After all, that's where the value will be created, right? Maybe not. Because throughout history, investors have repeatedly made the same mistake. They focus on the product, the consumer, the end market, the exciting story. Meanwhile, some of the biggest fortunes are quietly being built somewhere else. And if history is any guide, the biggest winners of the AI revolution may not be the companies everyone is talking about today. They may be the companies most investors have never heard of. The companies supplying the picks and shovels. And over the next decade, that could become one of the greatest wealth-building opportunities of our generation. Let me explain. Before we talk about AI, let's look at how major economic booms have created wealth throughout history. Because the pattern is remarkably consistent. Whenever a transformative opportunity emerges, investors rush toward the most visible winners. But the biggest fortunes are often built by the businesses supplying the infrastructure behind the boom. The businesses enabling it. The businesses selling the tools. Let's start with the California gold rush. When gold was discovered in California in 1848, hundreds of thousands of people rushed west hoping to strike it rich. Most didn't. Many miners spent years chasing fortunes they never found. But while miners were risking everything searching for gold, another group of entrepreneurs was making money regardless of who struck gold and who didn't. They sold the equipment, the clothing, the tools, the supplies. One of the most famous examples was Levi Strauss. He wasn't mining for gold, he was selling durable workwear to miners. Every miner needed clothing, whether they found gold or not. Samuel Brannan became one of the wealthiest men of the gold rush by selling mining supplies rather than mining itself. The miners were taking the risk. The suppliers were collecting the revenue. That's the picks and shovels model. And it's a pattern we'll see again and again. Fast forward to the railroad boom. Railroads transformed America. Investors poured money into railroad operators hoping to profit from westward expansion. But many railroad companies eventually failed. Competition intensified. Routes became oversaturated. Bankruptcies became common. Yet some of the greatest fortunes of the era were built by companies supplying the infrastructure that railroads required. Andrew Carnegie wasn't operating railroads. He wasn't transporting passengers. He wasn't shipping freight. He was supplying the steel that made railroads possible. When Carnegie sold Carnegie Steel in 1901, the transaction was worth approximately $480 million. Adjusted for inflation, that's roughly $18 billion today. The railroad operators captured the headlines. The steel suppliers captured enormous wealth. Then came oil. Most people remember the discoveries, the oil fields, the wildcatters. But one of the greatest fortunes in history wasn't built by finding oil. It was built by controlling the infrastructure around it, refining, transportation, distribution, storage. John D. Rockefeller's Standard Oil became one of the most dominant businesses ever created because it controlled critical parts of the oil ecosystem. Again, the pattern repeats itself. The visible opportunity attracts attention. The infrastructure opportunity creates extraordinary wealth. And today, we're seeing the exact same thing happen with artificial intelligence. Most investors are asking the same questions. Which AI model will win? Which chatbot will dominate? Which AI company will become the next trillion-dollar giant? But those may be the wrong questions. Because every AI company is competing for market share. Every AI company is fighting rivals. Every AI company risks disruption. Meanwhile, the infrastructure suppliers don't necessarily need to predict which AI model wins. They simply need AI adoption to continue growing. And that's where things get interesting. Because AI isn't just a software revolution. It's one of the largest infrastructure buildouts in modern history. Every time someone interacts with an AI model, an enormous amount of physical infrastructure springs into action behind the scenes. Processors communicate with one another. Memory stores and retrieves information. Data moves through high-speed networks. Optical systems transmit signals. Power systems deliver electricity. Testing equipment validates performance. Circuit boards connect everything together. None of this is optional. Without these technologies, artificial intelligence simply doesn't work. which means the AI revolution isn't creating demand for just one product. It's creating demand across an entire industrial ecosystem. And that ecosystem may be where some of the biggest investment opportunities exist. Let's start with memory. Most investors understand that AI requires powerful processors. What many don't realize is that processors are only one piece of the equation. AI models require enormous amounts of memory to train and operate effectively. Think of processors as workers in a factory. Memory is the warehouse supplying materials. If the warehouse can't keep up, the workers sit idle. As AI models become larger and more sophisticated, memory requirements continue increasing. Every new generation of AI hardware requires more memory bandwidth, more capacity, and more advanced architectures. In many cases, memory has become one of the most important components determining overall system performance. And unlike AI applications, memory suppliers don't need to predict which model wins. Every model needs memory. Next is advanced packaging. This is one of the most important AI technologies that many investors have never heard of. Most people assume that once a chip is manufactured, the hard part is over. In reality, some of the most difficult engineering challenges occur afterward. Modern AI systems combine processors, memory stacks, and specialized components into highly integrated packages designed to maximize performance. The challenge isn't simply building the chips. It's connecting them together efficiently. As AI systems become more complex, advanced packaging is becoming one of the industry's biggest bottlenecks. And bottlenecks are often where value gets created. Just as steel became essential during the railroad boom, advanced packaging may become one of the foundational technologies of the AI era. Then there's networking. This is where AI starts to look less like software and more like infrastructure. The most advanced AI models aren't trained using a single processor. They're trained using thousands, sometimes tens of thousands. These systems must constantly communicate with one another. And that communication happens at astonishing speeds. Every second, enormous amounts of data move between processors. The larger the AI cluster becomes, the more important networking becomes. A slow network can cripple a multi-billion-dollar data center investment. Which means networking isn't a supporting technology. It's a mission-critical technology. And every new AI deployment requires more of it. Closely connected to networking is another area receiving increasing attention: optics. As AI systems scale, traditional electrical connections become less efficient. Data simply needs to move too quickly. That's where optical technologies come in. Instead of relying entirely on electrical signals, optical systems use light to transmit enormous amounts of information with greater efficiency. As AI clusters become larger and more powerful, optical connectivity is becoming increasingly important. In many ways, optics may become the highways of the AI economy. And just as infrastructure providers benefited during previous economic transformations, companies supplying optical technologies may benefit from the growth of AI, regardless of which applications ultimately dominate. Then there's power. Perhaps the most overlooked theme in all of AI, artificial intelligence is incredibly power-hungry. Every new generation of hardware consumes more electricity. Every new data center requires more power. Every new AI deployment increases demand. Most investors focus on the processors. But processors don't run without electricity. And delivering power efficiently has become a major engineering challenge. Power conversion, voltage regulation, power delivery systems, backup infrastructure. These aren't glamorous businesses. They're not likely to dominate headlines. But they're absolutely essential. A modern AI data center is essentially a giant energy conversion machine. And as AI adoption grows, demand for power-related infrastructure may grow alongside it. Another critical area is testing. Every advanced semiconductor must be tested before deployment. As chips become more complex, testing becomes more important. The cost of failure is enormous. Imagine building a multi-billion-dollar AI cluster only to discover a defect after deployment. Testing helps prevent that outcome. And as AI systems become more advanced, testing requirements continue increasing. It's not the most exciting part of the AI story, but it may be one of the most important. Because every new generation of technology requires higher levels of precision and reliability. Finally, we arrive at one of the least glamorous opportunities of all: printed circuit boards, or PCBs. Nobody gets excited about circuit boards. But every advanced computing system depends on them. They connect processors, memory, networking equipment, power systems, and virtually every other component inside a data center. As AI systems become more sophisticated, PCB requirements become more demanding, higher speeds, more layers, greater complexity, stricter tolerances. Again, it's not the part of AI that makes headlines, but it's a critical part of the ecosystem. And sometimes the biggest opportunities are found in the least exciting places. Now, does this mean every infrastructure company will become a great investment? Of course not. History doesn't work that way. Some companies will execute successfully, others won't. Some valuations will become excessive, others won't. But that's not really the point. The point is that most investors may be focusing on the wrong part of the AI value chain. They're trying to predict which AI application wins, which chatbot dominates, which software company captures the most users. History suggests that's often the hardest game to play. The easier question may be, what does every winner need? Every AI model needs memory. Every AI model needs packaging. Every AI model needs networking. Every AI model needs optics. Every AI model needs power. Every AI model needs testing. Every AI model needs circuit boards. In other words, every AI model needs the picks and shovels. And if history is any guide, some of the greatest wealth created during the AI boom may not come from the companies making the headlines. It may come from the companies supplying the tools. Because throughout history, investors have repeatedly focused on the visible opportunity while overlooking the infrastructure making it possible. That's what happened during the gold rush. It's what happened during the railroad boom. It's what happened during the rise of oil. And it may be what's happening again today. The biggest wealth-building opportunity of the next decade may not be finding the next AI superstar. It may be identifying the companies quietly building the foundation beneath it all. The companies supplying the picks and shovels before everyone else realizes how essential they are. And that's a lesson history has taught us time and time again. If you enjoyed this video, make sure to subscribe, and let me know in the comments which part of the AI supply chain you think has the most upside over the next decade. Thanks for watching, and I'll see you in the next one.